Hello, today I like to present you our ultrasound measurement microphones MP30 Ultra with Zoom DAQ device and class 1 microphone calibrator. After we connected the Zoom USB audio interface to the PC, we have to make sure first that in the sound settings the input of the Zoom is set to 192 kHz. So we want to measure ultrasound. So with this device we can measure up to 95 kHz. So this is here set to 192,000 Hz. That's okay. Next, we have to install from Zoom homepage, or first download, then install from Zoom homepage Zoom Mix Control software, because we have to expand our measurement range. So for this reason I installed this already. And here we find the Zoom UAC, means USB audio converter. And we have now here some signals coming. Oh, yeah. So, and in the past, or some other USB audio interfaces from professional studio world, they have here at the input this volume or gain knobs, so where you can move it. So I prefer this device because if we once set this gain to no amplification, so if this is once done, so then we always save with our input gains. So that's all in this case here. This is done and that's fine. So means first we have to check the 192 kHz sampling rate. Is this set for ultrasound measurement? Yes. And then next here just set these sliders to the bottom so that it is 0 dB amplification. So that's all for this. So next, I like to introduce you our NVH analyzer software with the FFT function. So this software is made for scientific applications. So we can have here ASIO-based audio interfaces or classical measurement devices, like the Rogaduck series, Rogaduck 4, and Sinus Messtechnik and data translation is also supported with it. So I have here the 2-channel audio device because the Zoom is this audio device recognized by the PC. Here is already pre-selected and then just say apply. So now we want to make acoustics and FFT measurements. So this is now this part here. And this first, we see here the sampling rate. It's again 192 kHz. And here we have the sensor sensitivities of the microphones. So the physical unit is Pascal, and let's say the microphone, we don't know the sensitivity. Let's say here something with 500 or 1000 millivolt per unit. So the electrical range input of the zoom is 2.4 volt. This is important to keep this in mind. So here we can adjust the FFT line resolution. So that means I have here a distance from one FFT line to the next one of 5.8 Hertz. So here we can set FFT waterfall and so on. So that's okay. Set. So as first, it is I recommend to calibrate the channels as first, because we don't know is the complete measurement chain okay or not. So for this reason, I go back again here to setup, calibration. Also, we just arrange here the window a little bit smaller so that you can see what I do here, like this. So now I go here to the calibration menu. Like this. So, and my calibrator deliver 94 dB, but I can change it also from 94 to 114, but I use now 94 dB. So that's why here 94 dB. And now I put the microphone from first channel to the calibrator. Enable the calibrator. Now I say start. So now we see the signal is coming. So if I change, so here in this area, now I change to 114 dB. So this is exactly 20 dB more. So that's why I see here this value. But it's not calibrated. Now I calibrate it. Zack. Now it's done, 94 dB. Okay. Now I take the second MP30 Ultra. Switch here to channel number 2. Here we can see the old value. This is what I key in before. But the real value is 3.4 millivolt per Pascal. Start calibration, so now it's done. And now I can make again cross check. It's amplify 20 dB. Now we see it's 114 dB. Oh, okay, okay. 94.0. Stop. So now the sensor sensitivities now calibrated, or the microphones now calibrated, and of course I can save this setting. So yeah, we need here a little bit more place. So now as next we can start with the measurement, and if I want I can store also the raw datas. So So let's go to the which directory? So let's store this to the desktop. MP30 Ultra. Let's make a new directory. Raw data. So this is now record. Okay, so now let's assume I start the recording. So we can see here now from this channel we have here the blue between, let's say, 22 kilohertz and 60 kilohertz. We have here some kind of ultrasonic phenomena. So I know, here I can activate the calibration. So now we see here the 94 dB. So, and this ultrasonic phenomena is here from my lamp. So now I start record. So means on channel number 1 we have here now the calibration signal with 94 dB, and at the channel number 2 we have here the calibration signal of 94 dB, and channel number 1 is here the environmental noise. So I figure out that this ultrasonic phenomena between 22 kilohertz and 62 kilohertz is from bulb here. So I switch it off. So, and I stop now the recording. And now restart again. So the upper FFT here is averaged. The channel number 2 is not averaged. So that's why this is here still there, this signal. So it's also possible here to go through the phenomena. So for example here I see the calibration signal, okay, and then I can, for example, say, okay, this signal is something I need. So so now we can see here our 94 dB. This is now something I need. So, and then, because this Windows is already active, I can store and export this data. So if I hit alternate button and G for graph, I will get this channel number 2 in dB axis, and then I can export it. So means I can store here each phenomena, each FFT block. So if I move here to this one, zack. So I could store this also, of course, under another file name. So now the bulb is switched off. I make again a measurement. And now we can see that here this noise in the ultrasonic area is disappeared. So I have here a peak, but I don't know from which device this may appear. So now I have a typical ultrasonic source in a modern world. So it is a repeater. So I just power this. So before I start the recording, so means I use it now. I store now the raw data. So now I power it up here. So, and now we can see here that slowly, so because it's FFT averaged, we can see here that slowly some phenomena appear. So I move now this microphone into this direction. So now we can see that here the signal is increasing here in this area and also in this area. Now after the router find the connection to this repeater, now we can see here how the activity is increasing. So now I remove from this microphone calibrator the MP30. Now we can see here unaveraged the signal. So now like this. So now we make on both channels the ultrasonic measurements. Now I stop the recording. So now again the same I can do. For example, I can save or export the averaged FFTs. Again alternate and G for graph. So that means channel number 1. I export it. And now one. So it could happen that few days later we want to analyze again the signals, but this kind of devices are no longer there. For this reason it's good. So now I remove it. For this reason it's good that the raw data we recorded. So even, let's say, the zoom device is not longer available because it's on another place for tests. So now I leave this here. So now I disconnect it. So now it's not connected to the PC. So, and a few days later we want to again analyze this data. And in this case we have here the possibility to use this office function. So that means the NVH analyzer or the NVH FFT software don't need data acquisition hardware. So the setup should be stored. So as we have it adjusted previously. And now I just go here to load. And then I say here load recording. So now we have here this file which I just previously record. So now let's take the first record. So here is no much to do. We just see here the physical units and so on. Here we can export, if we want, this raw data to CSV or ASCII or text format, so that we can use another analysis software for post-processing. So I just continue it here. So, and now we can see here at the upper line our raw signal from channel number 1. So this is now channel number 2. This is the calibration signal. So, and now we can again start and playback. And playback the previous recording which we made a few days or a few weeks ago. So here we can see how the playback progress. So, and of course we can stop again and go here through the FFT blocks and export it, or we can go here to the display and then let's say I want to have here at the channel number 2 another function. For example, the sound level. By the way, sound level was A or C. It makes no big sense in case of ultrasonic measurements. So for this reason here, sound level, time domain level burst time. So now let's adjust here maybe 200 seconds. So this should be here okay. So, and here we can see now the level burst time. So this is now a little bit too slow for me. I'm not so patient. So that's why I change here the overlap to 1 and start again. So this is now much faster. The playback, so I can accelerate it. So, and here now we see the environmental noise. So after the calibration. So, and again, of course, we can use any other calculation methods with the NVH FFT software, like here 1/3 octave, and so on and so on. So here are many scientific algorithms for different purpose. So I hope this presentation will give you an impression how to use the NVH analyzer software with ultrasonic microphones and playback function and so on. So that's all for today. Thank you very much and have a good day.